If you haven't already, please print this handout. The previous lesson was about writing chemical equations and balancing them. Today we're going to look at different types of reactions. In this course, we're going to talk about 5 different types of reactions: synthesis, decomposition, combustion, single displacement, and double displacement. Now, you may have seen all of these in previous science classes, but we're going to revisit them today. So on the right-hand side, I've given you just a visual representation of what's happening in each of these reactions. So in synthesis, we have 2 chemicals added together, and they produce one new compound. In decomposition, it's basically the opposite. We're starting with a compound. It reacts and splits into 2 new chemicals. Combustion is a fuel plus oxygen forming carbon dioxide and water. So carbon dioxide and water are always the products in a combustion reaction. You basically start with an element and a compound in single displacement. The element displaces one of the elements in the compound. So you get a new element broken off of the original compound and a new compound. Double displacement, these are occurring between 2 ionic compounds. The metal cations switch spots to make your 2 new ionic compounds. So all of these reaction types were seen in the demonstration in the previous video. So if you haven't watched that, please go do that. I'm going to be referring to those reactions as we proceed down. The first reaction we saw in the video was between methane and oxygen. This was a combustion reaction. So the products are carbon dioxide and water. Now you may remember the blue flame was burning more efficiently, so that means the only products were carbon dioxide and water. Nothing else was being produced. So we call this complete combustion. That means all of the methane was used up to produce carbon dioxide and water. The yellow flame, that was a little bit different. This was called incomplete combustion. So not all of the methane was being converted into carbon dioxide and water. Other products were being formed, such as soot, which is carbon, and carbon monoxide, which is a poisonous gas. If you get that in your house, you're in trouble. The next reaction on the list is strontium nitrate and sodium sulfate. This was the reaction between those 2 aqueous solutions, and the product was cloudy. So we saw sodium and strontium switch spots. So the products were sodium nitrate and strontium sulfate. The strontium sulfate was actually that precipitate, the cloudy substance that we saw. The sodium nitrate was still dissolved in the water. I then showed you the Hoffman apparatus, where I was splitting the water into hydrogen and oxygen. The magnesium and oxygen was when that chalky white substance was produced, and that substance is called magnesium oxide. The next reaction was when I put the steel wool, which is iron, into the solution of copper 2 sulfate. And the brown substance that was produced was actually copper. So copper was one of the products. The other product was iron 3 sulfate. I'd like you to take a minute and think about what types of reactions are these last 4. Pause the video and then you can check your answers. So there you are. Strontium nitrate and sodium sulfate. The strontium and the sodium switch spots, so that's a double displacement reaction. the water split into hydrogen and oxygen. That's decomposition. Magnesium and oxygen reacted together to produce one new compound, so that's a synthesis. Iron switched with copper to make a new compound. That's a single displacement reaction. So the next thing I'd like you to do is to write out the chemical equations for all of these reactions. Start with just the skeleton equations. Pause the video and then you can check your work. You don't need to balance right now. So here you go. Here are the chemical equations for all of these reactions. I haven't balanced them yet, but just take a look at the formulas. You may have needed to look up the formula for methane, and that's okay. But I'm hoping that for oxygen or hydrogen, you remembered these are diatomic elements, so you need to have that subscript of 2 in their formulas. The next thing, once you have the skeleton equations, is to try balancing all of these. So pause the video and then you can check your work. And here you are. Hopefully you were able to balance those. Some of them were trickier than others. This incomplete combustion, that probably gave you some trouble, and that's all right. If you have questions about any of this, please email me.